All right. Well, we'll start out by doing attendance. So go ahead and click 1. No? Oh, well, no, it's open. No go, huh? Try some. Start again. Here we go. Go ahead. Yes? All right. So let's take care of some administrative stuff first. I handed out the schedule. All right. Let's see. Did Nakash or Jordan Vargas show up? No? Jordan or Nakash? All right. Anybody who did not get one of these today? Okay, so you didn't complete the online survey, this thing? No? Really? Did you add late into the class? Send me an email and I'll look up the records to see if for some reason it didn't go through. Okay, because it's a quiz grade. I don't want you to get a 0. Okay, so let me explain what I've done here. It's self-explanatory, but some people have a hard time with all this detail. Okay, so let me try and bring up a version that looks a little prettier. It's not much prettier. What's full screen again? I forget. F11? Okay, so what we're looking at here is the everyone who participated in the survey. It's kind of hard to tell, but these dark shaded areas here are when I'm in my office, and it goes straight across, okay? But if there's an OK there, then it covers up the shading. So anytime you have an OK on top of my shaded region, that means that I'm in my office and you say you're free. So I highlighted that for you. So if anywhere on your page where it's highlighted is where I'm in my office and you said you're available to study, which means you could come get help, right? And then where you see these like bars here, that's when I'm in class. So I'm not in my office, and like for example, Melinda here is free to study, but I'm in class, so that doesn't really help Melinda, does it? Right? Melina. Why do I keep on saying that? Really? Okay, I don't feel so bad then. Melina is free, but I'm not. But Melina can look and say, well, Juan's free, and Crystal's free, and Megan's free. And so what I'm hoping will happen, I don't know, I can't force you to become friends, but hopefully you'll start to see, what people in the class have similar schedules to you. And then what you can do is you can go into Canvas, you can create a conversation, you can invite just those people into the conversation or something like that, especially like before a test, right? These people are free when you're free. You get together, you study. Yes? Yes. Do you change your schedule as well? Well, I'm kind of fixed. I have to look at all 3 classes. I have 3 face-to-face classes. I have to see what would be most beneficial to everybody. What I'm looking at is, this right here, this number at the end. When I'm in my office on, Mondays, I have 3 students from this class, 6 students from this class that can come in. So, I can't make it perfect. It's hard to fluctuate my schedule because I teach and then I have other obligations. So I'm willing to, but I have to look at everything. I don't know if that answers your question. Yeah, I'm willing to adjust it, but it's got to be for the benefit of everyone. And here's the other thing. If I adjust my schedule because I have 20 students who can come see me at that time, I'm not sure that's even beneficial to you to have 20 students come see me. How am I going to help Cal 2 student, Cal 1 student, 14 student all at the same time? The best way to study is to form groups, and in front of our offices we have tables where you can sit like 5, 6 students. You form your group, you sit at the table, you study. When y'all can't figure something out, I'm in my office, you come knock on the door, I come help you out. Make sense? Okay. Okay. Does this all make sense? Now here's another thing that I'm going to use this for. After exam 1, if you're struggling If you struggled on exam 1, I'm going to look to see if you actually could come see me. There's only, I think, 4 people in here who have no time. It doesn't. If you have a little red X next to your sheet, Tatiana, you're one of them, right? That means that our schedules just don't work, right? So, but everyone else, you have time. According to you, you have time. So there can't be that, well, I couldn't come see you. Well, you said you could. So I'm going to hold you accountable to what you've said you plan on doing this semester. Or I won't hold you accountable. I'll ask you at least, why didn't you come see me? If you didn't feel ready for the test, why didn't you come talk to me? Any other things about this? Questions? Comments? No? I thought about doing like a sheet where you could voluntarily put your name and your phone number, but that's on you. If you want to do that, you do that on your own. I'm not going to sit here and, people don't feel comfortable with that. That's fine. I don't want to force you to. All right. What else? What are y'all voting about? Okay. So what are we doing today? We're supposed to do that, the thing that y'all were working on last time. I'm supposed to hand that back out to you, and you're supposed to continue to work on it. We are going to take a maximum of 45 minutes to maybe an hour. So at noon, we are definitely going to stop, and we need to start talking about section R7 and R8. All right? So questions on homework? Were there any questions on homework?
Yes.
Go ahead.
I got 103 and 104 and 139.
All right, so you're in R2?
Yeah,
R2, say again which number?
103, 104, and 139. Oh, it's number 103.
103. So this is in R2. This was number 103. And it gives you an expression, square root x squared plus y squared.
And the question is if x is 2 and y is -1.
It says for you to figure out what this expression evaluates to if you replace your x with 2 and your y with -1. All right? So here we go. First thing I'll point out is that because you have addition underneath the square root, you are not allowed to split this into 2 separate square roots. If it was multiplication, you could. If it's addition, you can't. Addition, subtraction, you can't. So you have to evaluate everything inside the radical first, which the thing inside the radical is called the radicand. You do all that first, then at the end you take the square root. So I'm going to come in here and replace my x with 2, and then square it. Add to that, I'm going to replace my y with -1 and square that. Now, notice my use of parentheses here. I'm not just having fun with parentheses. I mean, I'm doing that on purpose. I want everyone to realize that whatever x is, that's being squared, right? Whatever y is, everything has to be squared. So if it's negative, you're doing negative times negative, right? So squaring 2, you get 4. Squaring -1, you get 1. So this becomes square root of 4 plus 1, which is square root of 5. Yeah? Okay. Okay. 104, very similar. You're plugging in the same x and y, except the expression that you're going into is square root of x squared plus square root of y squared. So the way the problem is stated, it's separated, right? So you go in, replace square root 2 squared, square root -1 squared. Let's do a quick vote. How many of you looked at my solutions to these problems when you were trying to do them? Okay. 16 of you, 17 of you. Y'all gotta be quick. You either did or didn't, right? Okay, so if you don't know what I'm talking about, that's why I'm bringing this up, okay? Online on ACES, okay? All right, so if you didn't say no, we have 20 people? Yeah, it seems about right. Okay, so let's start again. Another quick question. For those of you who actually did look at them, did you find them useful? Okay. Because sometimes when you're looking at someone's solutions, it's still like, well, how did they do that? I tried to include as much work. So let's see if Northwest Vista's website's working this morning. It appears to be. So when you go into Canvas, go to my courses, find your class, which one is this? Here. Where do I go? Files. You can go here. And then Homework Solutions. And then you download them. I have them for R2, R4, R7, R8, and 1.4. I told you last time, though, I don't plan on doing this for the whole semester. We'll see. It's just a matter of time. Yes? Yes. Yes. Yep. So I hope that this little poll shows you that of the 10 people who did look at it, they found them useful. So it might be worth it for you to take a look at those. Okay, so back to this, sorry. This is what? Square root of 4, right? Square root of 4 plus negative 1 squared is 1. Square root of 4 is what? 2. Square root of 1 is 1, so you get 3 here. By the way, just so we're clear on something else, I thought that when you had a square root, you always had to look at plus or minus. Isn't there something about plus or minus with square roots? Right? So why am I not doing plus or minus when I did the square root of 4? Why didn't I do plus or minus 2? Yeah. So the reason I'm bringing this up is because I want everyone to be rock solid on this idea. If you are solving an equation or doing anything with an equation and you initiate the square root on both sides of the equation, if you are the one who actually comes in and does it, all right? Square root, right? Then you have to consider both plus and minus. Right, so the left side, square root of x squared is x. Here you have to say plus or minus 2. If the square root is there to begin with, then we call it the principal square root, and that means you don't look at plus or minus, you always just look at the plus. Pardon? Can I repeat everything I just said? If you take the square root on both sides, if you come in and do that operation, you have to include plus or minus, both the positive and the negative solution, if you initiate the square root. All right? Is that okay? Here we did not initiate the square root, right? It was there. It was already there. Okay. You may use a laptop, tablet to view lecture notes in class, but using any electronic device to do anything unrelated to this course will result in a 10% penalty on your next exam. That's the only person I'm making an example out of. The next person, that's 10 points right there. Got it? Okay. No texting in class. None of this under the table. All right? Take it outside. Go do something out there. I don't want it happening in here. You are responsible for knowing this policy exists, right? So I shouldn't have to do that and explain that. Okay. What else? One of what? 139. Was 139 assigned? Oh yeah, okay. So it gives you this equilateral triangle, like this. It comes labeled like this. All right. It says the area of an equilateral triangle is equal to the square root of 3 divided by 4. That's what it says. Times, I need to read this whole thing. The area of an equilateral triangle is root 3 over 4 times the square of the length x of one side. So they just want you to translate that into an equation. The area is the square root of 3 over 4. What did it say then? Times the square of the length of one of the sides. But the sides are, each of these sides are called x, right? So it's just the square of the length of one of the sides. It's just a translating the words into an equation. That's all that is. Okay, I have to cut. Was that a hand going up? No. Okay, I have to cut it off. I can't do every homework problem, obviously, right? I think using about 15 minutes is about tops of what I'll want to do any class, all right? I would advise that if you ever have questions on homework, you contact me prior to class, all right? Okay, clear your desks. I try and keep my word. I promised a quiz. I didn't want to let you down. If you have 5 people at a table like that, one of you just turn and go to the computer behind you, all right? So that it's not, everyone's not all crammed in there.
I didn't bring any calculator. Can I use my phone this time?
I don't think you need a calculator for this. If you do, raise your hand, and then I'll come by and ask you why you need it. Okay? So there's enough room to write on this, okay? So now, I don't think I need to bring up the policy on academic integrity, right? But basically in this class, cheating on this is like cheating on an exam, right? If I'm asking you to do this on your own, I expect you to do it on your own. I have zero tolerance for it, right? It'll be the last time we see each other. All right, so I'll let you go ahead and get started. What did I say I'd give you a quiz on? Well, this is 2 problems exactly from the homework. I didn't change a thing. I think there's there. Make sure you put your name on it. Extra? Okay. When you're done, bring it up and take the project thing back to your desk. That was your project 1. That was yours. Hanny? Where's Hanny? Hanny? Yes? Okay, I'm just giving you back your project work because you put your name on it. So after the quiz, you can get started on that with your group. Okay. Here we go. There you go. Okay, let's vote. How many of you think that that was a fair quiz? Who needs, anybody need one of these? Fair? Okay. Look, you can be honest, okay? You don't think that was fair? It's fine. Who needs one of these? No? The questions from last time? You need one? The questions from the project? Okay. Questions from the project? All right, so let's try this. Another question. How many of you did the homework? Here we go. See if there's enough there. Oh, no, vote up there. No, it's okay. We'll just leave it. All right. Okay, so now another thing. So we're saying 90% of you say that you did the homework. How many of you think that you did well on that quiz? So let's talk about this because this is what we have to figure out. If you're doing your homework and I come in here and I give you a quiz over 2 homework problems, then why would you not do well on that? I mean, that's what we have to figure out, right? So maybe there's a difference between doing your homework and actually studying math, like understanding it. Yes, you have a comment? Oh, I thought you were going to say something. Yes, Todd.
Well, I did kind of have the second one was like special substitution. It was like it went into the cubed root, and I didn't quite. I kind of figured it out right before class. He helped me.
For which are you talking about the quiz or are you talking about?
Yeah, the quiz.
The cube one.
Substitution binomial thing.
Okay.
Just had a little problem, but I got it.
Okay. I mean, we need to figure it out. I think as a class we should figure this out because I think this is the biggest problem, right? If you're doing the work, but then when it comes time to actually perform, you're feeling like you're not doing well, then how can you change that? I mean, what can we do to adjust that? What do you think? I'm looking for ideas here.
I just feel like the book adequately explained that second problem. They did square root of when I understand the.
What are you talking about, square root? I'm not sure what you're talking about. I don't have a square root on this quiz.
Not square root, cube root.
It's not cube root. It's a cube. It's a cube. Yeah, that's all right. I just want to make sure we're saying that. Okay. So
Saying because it's a shortcut to doing things. That's the way they explain it in the book. They wanted to do it as a shortcut
Got you.
And I didn't. I could do it the long way, but I was trying to do it the short way because that's the way you wanted it to slide out.
Oh no, there's no way I want it.
No. Okay.
I want it to make sense to you.
Okay.
Is what I want it to be. Let me see. Where's that problem? Right here. Okay, so let's look at my solutions that I put online for you and see if we can make any sense out of this. Okay? 2x plus 1 cubed, right? Means 2x plus 1 times 2x plus 1 times 2x plus 1. Now, what is this stuff I put right here? What does that mean? I'm going to do those two over here, like scratch work, right? And then how did I get from this to this? What did I do here? I distributed, like the FOIL, we call it FOIL, but it's expanding, yes. Yes? Where? Okay, either way, sorry. Yeah, well, it's a little screen, so maybe is it 2 on your screen?
Yeah, I mean, I took a picture from the book in the lab.
Okay, it may just be your resolution so low you can't tell it's a 3. The book says 3. Well, I'll look at it in a minute. Okay. I don't think you're lying. I don't think you're lying. I just, you take a picture. There's always that possibility. It looks a little different, but I'll check it. Okay, back to this. What did we do here? FOIL, right? So this times this, this times this, this times this, this times this. That's these 4 terms. Now, from here to here, collect like terms, right? 2x, 2x is 4x. Everything else stays. And then I come back over here and look, this stuff that was in red is now this, right? Okay, and then what happens? Multiply the 2x times this, 2x times this, 2x times this, and then 1, 1, 1, and then here they are, and then here's your answer, right? That's what you're supposed to do on that problem. So let me go back to this and try and talk a little bit more about this. I do not mind putting the effort in to create solutions for you, but not if those are the results we're going to get. You know what I'm saying? It has to be used in a way that it's constructive to you and that you can then come in and perform and not look at that 2x plus 1 cubed and be like, well, I just had no idea what to do. Understand? So you're going to have to work on, if I'm going to give you a quiz every single day at the beginning of class and it's going to cover homework, and this was probably the only quiz where it's exactly homework. I mean, from here on out, I'll change numbers and change different things, but if that's going to be the procedure the rest of the way, you've got to find a way to not only do your homework, but then to go back and review it, look at what the different techniques you were using, okay, and be comfortable with those. Get that all clear before you come into class. Go get help. Go ask questions. Don't do your homework 2 hours before class, because if you run into a problem, where are you going to go? You know? Okay. So how about this project thing that we were working on? I'm going to give you, let's say, I'm going to give you 20 minutes to work on that. You know what I'm talking about? The code breaking thing. And if that is not done in 20 minutes, which I doubt it will be, then what we're going to do is we're going to make it due next Thursday. All right? So I would hope that you would work together in groups outside of class, but you'll be responsible for turning in your answers on Thursday of next week. Pardon me? Yes, you get to keep all this today. All right? Well, let's see how much you can do in the next 20 minutes. And I'll come around and help out. I'll be right there, ma'am. And so that we're very clear, I'll write this down. The project is due a week from today, which would be Thursday, the 27th. Is that correct? At the beginning of class. You are definitely allowed to work together. Is it the 29th? Oh, yeah, it is.
If somebody else already did the work on one problem, and we just say they did it, or we have to go over the problem.
Well, you know, when I was in graduate school, we used to have this thing called divide and conquer, where we would each take one problem from the take-home test and go work on it, and then get together. But we would get together and we would teach it to each other. So there's a difference between just copying somebody else's answer and you understanding. Everything on here is something that's beneficial to you. So understanding everything on here is only going to help you in the long run. I don't know if that answers your question. You know, I can't stop you from copying other people, but at the end of the day, it's your learning here. So, okay, so that's due Thursday. I had said that I would offer, I think on the bottom it says I'll offer a bonus of like 3 points or something on the first exam to the first group who's done. We're just going to have to throw that out because no group was able to accomplish it in the amount of time. So there won't be any bonus for the first group. I think that's only fair, right? Because someone will leave here, go take it to their friend who's an engineer, they'll finish it, and they'll send me an email with the answer, and that's not the point. Okay, since I had the website up, I thought it would be useful to look at this schedule here. If you click on schedule, it'll download a printable schedule that shows the day-by-day, blow-by-blow list of what we're supposed to be doing and the corresponding homework assignments. So last class, these were the homework assignments that I gave you. Right, so I suggest maybe printing this out and just sticking it in a folder, and that way you always have it, or save it on your phone as a PDF. It is a PDF, so you can just save it on your phone. It's also in files. You can find it there. And then also, I had mentioned before, last class, I held it up, that there was this document that I had for the exam. Exam info. Homework exam 1 material. I can kind of bring this up and show this so everyone can see it now. I copied this. I know some of you had Ms. Collins last semester, so like I said, this was my first time teaching 1414, so I used a lot of her stuff. We are actually, as a faculty, getting together and creating an exam for this class for the first exam. Now, we're not all going to use the same exam, but we are all going to collaborate, talk about what our first exam is going to look like in all of our 1414 classes. And we're all going to agree on what an A-level problems are and B-level and C-level problems. So if you go and you look at section 1.4, which is really the first section of new material in this class, then these questions, 11, 19, 22, those, if you can do those, you're at a C level. If you can do these, you're at an A, B level. When we make exams, 70% of the problems, 70% of the problems are C level. 30% are A and B. So if you can do all the C level problems, you should get a C on the test. But if you can do the C's and the A's and B's, then you get an either A or B. Does that make kind of sense to you? All right. But this is pretty good because it actually goes and shows you, like, all right, if you're struggling with these problems right in here, that's really going to limit your ability to get that A on that test. And then there's warm-up problems. These are like, we're not even going to ask you these, but it's kind of like building blocks. You need those before you can get to the next level. I said I wouldn't waste time showing you the website, but the class lecture videos, now if you click on this, it should take you to my YouTube channel. It should take you to this class, and you can see our day 1. So last class, the lecture I had is right there. After today, the next one will be below that. Okay. And future reference, if you click playlists, then you can bring up everything, all my old classes. Now, I haven't done 1414 in the past, so that's no use to you. But moving on down the road, if you get into pre-cal and calculus, and I've got semesters and semesters worth of videos for that, FYI. All right, let's get down to business. We are still reviewing, okay? I consider what we're going to talk about right now review, so I'm not going to present it like, you know, a brand new topic. Like, here's a definition, here's a theorem, or anything like that. It's going to be, hey, here's a problem, let's see how you can handle this, all right? You should have seen something like this before. So I'm going to work straight out of the book in R7. What does the R stand for? Review. Okay, make sure. We're in the review chapter. R7 is called rational expressions. Rational expressions. Rational expressions and your ability to manipulate rational expressions is absolutely critical in Calculus 1. How many of you need to take Calculus 1? Just show of hands. All right? This is the biggest hurdle for a Calculus 1 student, is their ability to algebraically work with rational expressions. So we're supposed to touch base with it, you know, in here, and we will. We'll get very deep into rational expressions. But this is just a review of some of the things you should know. So let me just pick some problems. I'm going to do some problems that are kind of close to the ones in your homework. So you're supposed to do number 12. Let me do number 13. Oh, yeah. I'll do, that one doesn't look hard enough. Here, I'll do this one, 13. So I'm doing number 13 right out of the book. It's x squared plus 4x minus 5 divided by x squared minus 2x plus 1. The instructions here are to reduce to lowest terms. In other words, simplify this if at all possible. Can everybody see this clearly? It's not too bright in here, all right? All right. So one of the things I said is going to be absolutely vital for you in success in this class is your ability to factor. If factor is still this thing that's just this big dark cloud over your head, you've got to get it cleared up very, very quickly, all right? Because I'm not going to take time to actually teach factoring in here. I'm going to assume that you have a way of factoring this. So we look at this, we say, all right, we have a rational expression, rational ratio. So we have an expression that has a fraction involving variables, right? And I'm trying to simplify it. Remember with fractions that if you have something like 5 times 4 over 5 times 3, I can cancel the 5s or not? Yes, why? There's multiplication between the 5 and the 4, and there's multiplication between the 5 and the 3. So you can cancel things when there's multiplication. When you have 5, let's go 5 plus 4 over 5 plus 3, you cannot cancel, right? Because they are separated by addition. Same thing here. You cannot say, oh, cancel the x squareds, right? 4x divided by negative 2x is negative 2, and negative 5 divided by 1 is negative 5. You can't do that. For the same reason you can't cancel stuff here. So the only way you can cancel is if you can factor this, make it multiplication. So we take the numerator. It is a trinomial, right? Quadratic, trinomial. So you have whatever method you have to factor that into hopefully 2 binomials, two terms in each factor, right? Okay, so what is the factorization of this numerator? X plus 5, x minus 1. Bottom? Yep, both of them are the same, right? Okay, let's vote. And you can be honest, right? I'm not going to hold you to this. How many of you are okay with factoring trinomial like that? And not only okay with it, at the speed of which I just did it. Is it not voting? Oh, you can't see it. Hold on. There we go. Okay? Okay, good. I was looking for 80%, right? That's what we're shooting for? So the 18% here that feel uncomfortable with this, it has to be addressed. All right? That means go to the tutoring lab. I need help on factoring. Trust me, you will not be the first person to ever walk in there with that issue, all right? So, and now what can we do at this point? Cancel like factors, right? So I could cancel this x minus 1 and this x minus 1. And then what I have, cancel or reduce, the same. It's not exactly the same thing, but we'll just use those words interchangeably. Interchange those without issue. So that's what it becomes, right? Now, there is a subtlety here that we have to be aware of, especially in a calculus class. Here it's not as important, but it's the idea that this expression here is equivalent to the one up there. They're equivalent. So if I plug in, let's plug something in here that's easy, like how about 0? Plug 0 in for x here and tell me what you would get. 0, this would be 4 times 0 would be 0, right? So you get negative 5 up top. 0 down here, you'd get 1. So you get negative 5 over 1. Okay, so what about 0 into this one? Same thing. And it turns out that doesn't matter what x you plug in, it will give you the same result here as here. Except there's one place where you have an issue. When you canceled this, right? You had to kind of make a little prenup. I like that, like a prenup, right? Like an agreement that you made before you did it, right? And that's, I'm going to cancel that with this one consideration that I can never let x be 1. Because if I let x be 1, I would actually have division by 0 here, wouldn't I? Yes? So what we're saying is that those expressions are equivalent as long as I'm doing it in a different color, so you know that you don't need to write it down, but you need to be aware that it's there. So long as x is not 1. This is equivalent to this so long as x is not 1. I'll give you a more simple example of this. All right? Tell me if these are the same expressions. That versus 1. Are those the same expressions? Okay, if I plug in 4 over 4, I get 1. 5 over 5, 6 over 6. So you would say, all right, x over x just cancels out and becomes 1, right? I mean, algebraically, these just cancel and you just get 1. But try plug 0 into this. What's 0 divided by 0? No. 0 divided by 0 is a conundrum, all right? It's undefined. 0 over 0 is one of the most interesting things in mathematics because you've always been taught anything over itself is 1, right? But 0 is kind of the exception. I mean, think about all the contradictions that are happening here. You're told that anything over itself is 1, so this should be 1 maybe. But you're also told that if you take 0 and divide it by any number, that should be what? 0. And then you're also told if you take any number and divide it by 0, it should be undefined. So this is like I don't want to use bad language, but it's just a cluster of issues here, right? It's a bunch of things happening that are bad. And this is what calculus is going to address. Calculus is going to address that situation, all right? So I'm trying to get you to see that these two expressions are not equivalent. They are as long as x isn't 0. If x is 0, then they differ. If x is 0 over here, it doesn't do anything. If x is 0 over here, it's undefined. Okay. Let me give you something else. How about this? Number 20. Your homework problem is number 25, 27, 29, 31. I'll do 26. 12x over 5x plus 20 all over 4x squared, x squared minus 16. If any of you are uncomfortable as far as the way that the chairs are, you need to rotate tables or something, you know, just you got to work that out with your little table if that's the issue, okay? All right. Well, look, this is it's a rational expression, okay? We're supposed to clean this up, make it look nice. But these are what we call complex fractions. Why do we call them complex fractions? They look complicated, don't they? I mean, they look complicated. And it's anytime you have fractions within fractions, you get complex fractions. So this is, I don't know if y'all can see this here. We talked about this last class. If you have a fraction divided by a fraction, it's equivalent to multiplication of the reciprocal. Remember me saying that last class? So it was this whole idea that if I take a fraction, a over b, I divide it by c over d, that's the same as taking a over b and multiplying it by what? D over c. So you leave the numerator fraction alone, you multiply it by the reciprocal of the denominator. That's just the definition of division. We also talked about the division bar, that you had to be able to identify which was the big division bar. Can you all tell that's the big division bar? Okay. So let's rewrite this first. This is equivalent to 12x over 5x plus 20 times what? X squared minus 16 over 4x squared. We all good with that? All right. Thank you. Whoever voted. You can vote as you want. Whenever I really want you to vote, I'll tell you. But if you just want to sit there and as I ask questions do that, that's fine also. Because if I see all of a sudden a bunch of red, I'll know to stop. Now, we said we can cancel things as long as they are factors. The only factors I have are, because the multiplication is here, is I'm treating this as a factor, and this is a factor, and this is a factor. Nothing cancels yet. I need to have some experience with these polynomials and recognize some of the factoring that I can do here. How about 12x? Can't really do anything 12x. 5x plus 20? You could pull a 5 out of that, right? X squared minus 16. So that, what do we call that? A difference of squares, right? Difference of squares. And then 4x squared can't do anything with. So I'm about to do what we would consider a GCF factor in here, greatest common factor of a 5 out of these two terms on the bottom left, top right, difference of squares. Here we go. 12x over, when I factor a 5, I'm left with x plus 4 times, now difference of squares, x plus 4x minus 4. Bottom right is 4x squared. So this to here, difference of squares. Pardon me? These x plus 4s can cancel now. They can cancel because it's multiplication straight across. Now, you could do it right now in this step. I'm going to show just one more additional thing here. I'm going to group them all together into one line like this. You don't have to show this part. I'm just trying to show a lot of detail here. All I did was, if there are two fractions and I'm multiplying, I just go straight across. So what's 12x times these two? Well, it's 12x times those two. All right, what's straight across on the bottom? Well, this 5 and the 4x squared become a 20x squared, and then this x plus 4 just sits there next to it. I'm only doing that so I put it all together in one fraction, then I start canceling things, and I can actually do some other stuff other than canceling. What else can I do here? Oh, you mean like multiply it through? Before that, though. 12 and 20 have a common factor, so that's a fraction that can reduce, right? What number goes into both 12 and 20? Biggest number you can think of. 4? Okay, so I divide 12 by 4, 3. Divide 20 by 4, 5. So 12 over 20 is the same as 3/5. And then what about x over x squared? What about that one? X over x squared. Let's talk. There's two ways of doing this. Hey. You subtract the exponents, that's one way. So if you did that, you would look at what? X to the first power over x squared is x to the 1 minus 2, right? And then that's x to the negative 1, which is really 1 over x. That's a long way to go to get to this result, but that is a proper way of doing it. Another way is just to sit here and think about it. I mean, it's like that's x over x times x, isn't it? And then one of those x's goes away, so you're just left with 1x on the bottom. Either way, it's going to turn out, it's going to leave us with 1x on the bottom. Yes? Okay, so I'm going to write the final answer here. I've got the 3 that was still there. This x was gone, right? That one I just circled there in green. One of the powers down here went away. I had the x minus 4 up there. And then on the bottom, I had the 5 there. The x was still there, and that was it, right? That would be an acceptable answer. So would this. How's it going? Are you Jordan? Okay. Did you just add into the class? All right, just have a seat. Let's talk afterward.
So I need to go.
Oh, you got to go back?
Yeah, I need to go back.
You don't have a pen? Pen? A pen? There you go. But you will be coming into this class? All right. Are you free after this? After that, are you free? Try and come back? Okay. All right. Real quick vote. We good or not? It's always easy watching someone do it, right? It's a little different when you're sitting there on your own. But as far as the process, the method, everyone's all right with it? All right, let's get something a little more complicated then. How are we doing on time? 20 minutes? I'll go quicker through this one. Maybe. X squared plus 7x plus 6 over x squared plus x minus 6. All of this over x squared plus 5x minus 6 over x squared plus 5x plus 6. Can you tell where the long division bar is there? Okay. So this is just going to turn into multiplication of the reciprocal, isn't it? Okay. Sometimes, and I'm not going to encourage this, but I know as long as I've been teaching, I tell people, you need to get good at writing your math out. You know, like if you're in an English class, you know, you don't write sentences without periods and punctuation. In math, you need to start to learn how to write a little more clearly so that you can go back and read your own work. And perhaps I can understand what you're doing too. So don't skip anything, I guess what I'm trying to get at. Show the work. We're not going to run out of paper, right? We're never going to run out of trees. Just kidding. Are you worried about saving the trees? Just recycle. We don't have trees. We don't have oxygen. I have a recycling theory. I'll share it with you sometime after this problem's done. Okay. Any questions? Flip the fraction. We good? All right. Now, this is a bunch of can you factor trinomials or not? So this top left up here, what does that become? X plus 6, x plus 1. Bottom left. X plus 3x minus 2. Good. Top right. X plus 3x plus 2. Bottom right. X plus 6. X minus 1. Now we can cancel factors if we have them. So let's see. X plus 6, x plus 3, that's it, right? So what's left is x plus 1 times x plus 2 over x minus 2 times x minus 1. And that's the correct answer. You box that up, you're done. Now, someone will always ask, you know, can I multiply these back out? Can I expand those back out? Yes, you can. Still, it's okay to do that. But later on in calculus, you're going to be very happy when you're at this point. You just leave it factored, because what you'll be doing is eventually setting it equal to 0 and doing things, solving equations. And all right. Let me see if I can push a little bit harder here. Not too hard, but how about if I give you 3x over x minus 4. By the way, this is number 48 in the book, plus 2x over x plus 3. This is number 48 in the book. The difference here is that we have addition between two fractions, right? Instead of multiplication. So because we have addition, remember that when we were learning about fractions, adding fractions is harder than multiplying them, right? Because you have to have the same denominators to add two fractions together. So we would have to get a common denominator in order for this to work. So we go find what's called the least common denominator. And that's just, we look at both denominators and we need both of them, right? We need common factors. So we need x minus 4 and x plus 3. We need both of them. And then if this is our least common denominator, what we have to do is we have to take the original problem, we need to rewrite it so that each of these denominators has this in it instead of what they have, right? So the way that I like to do this is I just write it again. Okay, so I just rewrote the problem, and then I'm going to multiply both sides, or not both sides, it's not an equation. I'm going to multiply each fraction by a very special one. Okay, you don't have to write that one down. But what is the one we are going to multiply this one by? X plus 3 over x plus 3. Right, x plus 3 over x plus 3 is 1. Multiplying something by 1 does not change it. So I'm going to just make it look different even though it's going to be the same thing. And then over here, what's the one I'm going to introduce top and bottom? X minus 4. So let me come in here and replace these ones with exactly what I'm putting in here. It was x plus 3 over x plus 3. Then over here it was x minus 4 and x minus 4. And then what you do is you actually put these together. You multiply them together. And you multiply these together. When we multiply fractions, it's straight across, isn't it? We're doing the yellow and we're doing the green separately, right? Yellow, we're going to multiply those, do the green, figure out what those are. Another thing I'll point out here, in this red parentheses, why am I putting those in parentheses down here? That's right. This x plus 3 and this x minus 4 multiply together. I'm actually not going to do those. I'm not going to multiply them. I'm just going to put them next to each other, right? Just leave it. Okay, let's multiply the top over here. What would you get if you multiply the top?
You get 3x squared plus 9.
3x squared plus 9x.
And 2x, you'll get 2x squared plus minus 8x.
Okay, so I'll get over there in a second. That's my first fraction. My second one is 2x squared minus 8x over x plus 3 times x minus 4. Yes. Quick vote. Let's see where everyone is. Are we good with this or not? All right. I have a common denominator now, right? So I add them together. When you add fractions that have the same denominator, you leave the denominator alone and add across. Now, it does get tricky if this is a minus, doesn't it? Like if that's a minus, it actually changes the signs here, both of those. But it's a plus, so it doesn't change anything. So I'm just going to do, yeah, can I just do it all now, just mentally? It's 5x squared plus an x over x plus 3 times x minus 4. Now that's good, but I'm going to just check one quick thing. Can I factor an x out of the top? Why would I do that? Why would I factor that x out of the top like that? What if I actually had a factor that canceled here, right? Could have happened. So recognizing that there was an x in here and pulling it out was something you should just always be ready for, right? I say just go all the way to this. Yep. Now, if nothing cancels, then you can multiply it all back together, and that's what the book might have. I think the book leaves them factored. Yeah, the book most of the time leaves them factored out, just like this. Like 5x squared plus x, and then even multiply these two together. But it's just more work. I say box it up. Be happy, move on. All right. Let's try this. Number 62. How much time do I have? Got 10 minutes, right? X over x minus 3 minus x plus 1 over x squared plus 5x minus 24. Subtraction, right? I need the same denominator. So I need to recognize that this is a trinomial again. I'm going to try and factor it out because I'm hoping that one of its factors will be x minus 3, so I won't have to, like I already will have an x minus 3 over here. Let's see what happens. It is x plus 8 and x minus 3. So we're somewhat happy about that, I guess. Okay. At this point, I start looking for the LCD. LCD, I'll need the x plus 8, right? And I'll need x minus 3. Okay, when I say LCD, what I'm saying is, what is it that I need both denominators to look like? What do I need both denominators to contain? They both have to have an x plus 8. They both have to have an x minus 3. The fraction on the right side is ready to go, right? I don't have to touch that one at all. The one on the left, I'm going to have to introduce the x plus 8 on the top and bottom. Make sense? Okay, so let's go ahead and rewrite it again. Don't worry about paper. It's good. Now your hand's starting to hurt. It's a different story. All right, so here I'm going to introduce my 1, x plus 8, x plus 8. Throw those in parentheses. I'll even throw that x minus 3 in parentheses down there. Okay, so real quick, what if this up here, just for the sake of discussion, what if this was x plus 4 up here? Up here, right here. You'd have to put in parentheses and then like FOIL it out. Be careful with that. If that happens, if this numerator has 2 terms in it, then when you multiply times this, you have to do FOIL. I can't stand FOIL, but everyone knows what I'm talking about when I say FOIL. Proper word is expand. It'll become a trinomial. Yep. So let's go ahead and do this. Let's see if I can do this all in one step. X times x, x squared. X times positive 8 is positive 8x. They will have the same denominator now, right? So I'm just going to put it together with this numerator, but I'm going to subtract it, which is going to make it a what? Minus x minus 1, right? Minus is coming from this negative sign, actually distributing through and changing the signs of what was here. They were both positive. They're now both going to become negative. As you might imagine, that's one of the biggest mistakes that I see on things like this, right? The most common mistake I see there is a student, instead of putting this, which is correct, they'll put minus x plus 1, right? So they put the minus on the x, but they forget to do it to the 1. And we're pretty much there, right? X squared plus 7x minus 1 over this thing. Now, we do have to talk about this. The top is a trinomial, right? Does it factor? There's no method that we have that's going to factor that and get us nice numbers. So we're done. I've got 6 minutes. I think I can squeeze one more in. I didn't quite get through all of R7. R8, I think, is a review, a true review. It's like square roots and cube roots and stuff like that. It's not as hard as R7, or yeah, R7 is. Look at this one. 2 minus x plus 1 over x. All of this over 3 plus x minus 1 over x plus 1. The instructions here are to simplify this. Now we're starting to get to some more challenging sort of complex fractions. We have a big fraction. We got little fractions. But these little fractions are next to these whole numbers. So where do you even begin? Multiply by the reciprocal. So think about this, though. If I understand what you're saying, but is this fraction up here look like A over B and then over C over D? Do you understand what I'm saying or not? Does this look like A over B over C over D yet? No, because this top right here is not something over something. It's something minus something over something. So why don't we put these two together into one fraction, and then they will look like this, won't they? So to put these two together, I actually have to recognize that 2 as being a 2 over 1, right? And on the bottom, I'm going to need to do the same thing, so I'm going to need to realize that's a 3 over 1. Okay, let's try and put just these two together right now. What would the least common denominator be here between these two? X. So I'd have to multiply the top and bottom right here by x, wouldn't I? So if you multiply top and bottom here by x, what would it become? See, now I'm skipping some work. I'm not going to be showing all this. I want to see how we follow with this. What would the next one be? 2x. Let's go a little slower. 2x over x, that's what that would become, minus x plus 1 over x, right? So all I did was I introduced an x on top and bottom here. How about over here for the bottom one to put together? What do we need down here? X plus 1, top and bottom, right? So let's see what that would turn out to be. 3, you're multiplying times x plus 1 over the x plus 1. That's what you told me to do, right? This 3 multiplied top and bottom here by x plus 1. And then over here, leave this one alone. So plus x minus 1 over x plus 1. Let's vote real quick to see if you follow that or not. Okay, that's great. Now let's put these two together up here, right? Same denominator, squeeze them together. Be careful, you have a minus. So change the signs to become negative x minus 1. So what's 2x, take away x, take away 1? X minus 1? Ah. And what's that on top of? The common denominator, x. All over? We never distributed that through, did we? This highlighted part here in yellow, we never figured that out. It was 3x plus 3, right? Right there on the side. So now when we add them together with this part right here, you get 4x plus 2. Yes? We'll ask in a second. 4x plus 2 over x plus 1. And then you continue and you do what we did earlier. Okay, now you have the a over b, c over d. Quick vote here. Did I lose anyone there? Uh-oh. Yes? Okay, so what I'm doing is I'm taking this 2x, right? I'm subtracting this. So that's the same as when this minus goes through in here, That becomes negative x and then minus 1, doesn't it? And then in the front I had what, 2x? Right? This one right here, 2x, and then I'm taking away this x and taking away the 1. 2x minus x is x, that's here, and then minus 1. Got it? Everyone okay with this? Oh, wow, I lost a lot of you on this part. Okay. Vote again and see if that cleared up anything. Okay, so what else? Down here? This right here, well, let me say the whole thing here is 3x plus 3 over x plus 1, right? This other one over here is x minus 1 over x plus 1. There's a plus sign between them. So you go 3x plus 3 plus x minus 1. 3x plus 3 plus x minus 1. And when you keep that over the common denominator, x plus 1. And then when you put that together, you get 4x plus 2. Final vote? You only need to change it if, okay, good. So at this point, we're back to what we were doing earlier. We're out of time, all right? So on your homework, there's going to be problems that are a little more challenging than this. I'm going to keep the quiz for next class geared towards what we did here, okay? There's problems from R8. You need to go do them. But my quiz is going to be purely over R7, all right? All right, everyone. I think that's it, right? Make sure you put your clickers back. Is there anything else that's due? How about that confirmation quiz? Was there a quiz online? The syllabus confirmation quiz is due tomorrow night. You do it online. Bring it up. If you don't know what I'm talking about, I'm bringing it up right now. Syllabus quiz is right here. Right here. You click it, and it's going to ask you a yes or no question. Well, for me, the instructor, I don't get to see it, but yes. No, the syllabus is right here. Syllabus is right there. Yep.
And then where was the quiz?
Right here. Yep. Everything you need is right here on this first page.
You called me earlier.
I called. Oh. This is Canvas, yes. Yep. Okay, hold on a second. Let me give. Okay, so this was just to see like when other students in the class are studying, and you're one of my students that you're. You know what? Hold on, I'm still recording. Let me.